Welcome everyone. Can you find area of this brown semicircle? Where given to us is area of this blue and purple quadrants as 2 and 4 centimeters square each. For each solution, we have to first establish the relation between the radius of this blue quadrant and the purple quadrant. We know that the area of quadrant is given by 1 by 4 times of pi r square. So for blue quadrant, it will be 1 by 4 times of CE square, and purple quadrant, it will be 1 by 4 times of CD square, and this area is given by 2 by 4. Simplifying it, both the side 1 by 4 pi will get cancelled down. Taking square root on both the side and writing it by cross multiplication, we will get CD as root 2 times of CE. So if we'll assume the radius of this blue quadrant as r centimeter, then the radius of this purple quadrant, that is CD, will be root 2 times of r. So this length CD, that will be root 2 times of r. So this relation will be using in all the three approaches. Let's check our first approach, which is we'll be using power of Pine theorem or intersecting chord theorem. For that, let's drop a perpendicular from point D on AB. Now here this figure, that is DFEC, has all angles as 90 degree, so it's a rectangle, and thus DF length will be same as r centimeter, and FE length, that will be same as root 2 r centimeter. And let's assume AF length is a centimeter. Now here, if we'll assume this semicircle as a complete circle and extend DF to meet the circle on other part at D dash. So here we have got two chords, one is AB and another chord is D dash. These are intersecting at point F. So applying intersecting chord theorem, for that this DF is R, so FD dash, that will also be r centimeter. So here we have AF times FB. AF times FB is DF times FD dash. AF is a centimeter, FB is r plus root 2r, and DF and FD dash both are r centimeter each. So this, simplifying it, we will get A as r upon root 2 plus 1. Rationalizing the denominator, we will get value of A as r times of root 2 minus 1. Now here if we will see AB is the diameter, and thus it is equals to 2 times of capital R, where capital R is the radius of this semicircle. So 2R is A plus root 2R plus R. So this is your AB is 2R diameter. This is equals to A plus root 2R plus R. Here putting the value of A as R times of root 2 minus 1. Now adding it and simplifying it, we'll get 2R is 2 times of root 2R. So here 2 will get cancelled down. So here we are getting R. The radius of big semicircle is root 2R. Root 2R is the radius of this purple quadrant. So radius of this purple quadrant and radius of this brown semicircle is same, and thus the area of this semicircle will be 2 times the area of this quadrant. So area of this big semicircle is nothing but 2 times of 4 or 8 centimeter square, and that's our answer. Now let's check the second approach for the same question. For our second approach, we'll use concept of similar triangles. For that, let's join DB here and let's join DA. Now here AB is the diameter, and we know that diameter always subtends an angle of 90 degree. So angle D here is 90 degree. Let's assume this angle B here is alpha degree. Thus this angle here, that will be 90 minus alpha, and full angle is 90. So the remaining angle will again be alpha degree. So if you look at the triangle DFB and this triangle, that is AFD. Now both the triangles are right angle triangle and both have got angle alpha degree, and thus by angle similarity both the triangles are similar to each other. As the triangles are similar, thus the ratio of corresponding sides will be equal. So we can say here that DF upon FB will be equal to AF upon FT. So putting the values here, DF is your R centimeter, FB is root 2R plus R, and AF is A centimeter which we have assumed, and DF again is R. Cross multiplying and simplifying it, we'll get A as R upon root 2 plus 1. Rationalizing the denominator, we'll get A as R times of root 2 minus 1. And again same approach, AB is the diameter which is equals to 2R and also equals to A plus root 2R plus R. Putting A as R times of root 2 minus 1 and simplifying it, we'll get 2R as 2 times of root 2R. Both the side 2 will get cancelled down. We'll get R as root 2R. So the radius of this semicircle is same as the radius of quadrant, and thus the area of this semicircle will be 2 times the area of this quadrant, or the area will be 8 centimeters square, and that's our answer. Now let's check the third approach, the most elegant approach for this question. Let's check the third approach, the most elegant approach, in which we'll be using just basic concepts of geometry related to rhombus. So for that, let's first join BC here. Now this is a right angle triangle is getting formed, isosceles right angle triangle, in which BC is the hypotenuse, which we can find by using Pythagoras theorem as root 2R. Now CD length, this we have initially established as root 2R. Now here with BC and CD as two side lengths, we are drawing a rhombus. For that, from point D, we'll draw a line which is parallel to CB. And this diameter, this is already parallel to DC. So here this figure formed is a rhombus with each side length as root 2R. So now what we are doing is we are drawing the diagonals of this rhombus. So let's draw both the diagonals of the rhombus, and we know that diagonals of rhombus are perpendicular bisector of each other. So this angle is 90 degree, and if you look at here, DB is the chord of the circle also, and a perpendicular bisector, by theorem the perpendicular bisector of chord passes through the center of the circle. So this point here is nothing but center of the circle. And here if we look carefully, DO is what is the radius of this semicircle. So here we can say radius of this semicircle is root 2R, and as radius is root 2R, which is same as the radius of quadrant, so we can say area of this semicircle is 2 times the area of quadrant, so which is 2 times 4 or 8 centimeters square, and that's our answer. I hope you enjoyed the video. I will see you in next video. Till then, tata, bye bye.